Question 9.15. The mass is 3.1 kilogram. 3.1 kilogram block of wood sits on the frictionless table. A 3-gram bullet fired horizontally with a speed of 490 meters per second goes completely through the block and emerging at a speed of 200 meters per second. So let's start off with the figure. 3.1 kilogram is sitting here. Here's the bullet. The bullet is going with 490 meters per second, and the mass is 3 grams. And then after it goes through, it is emerging with 200 meters per second, and the mass must be still same. The question is, what is the speed of the block immediately after the bullet exit? So this is the question of conservation of momentum, which says momentum before is equal to momentum after. What is momentum before? It is moving bullet and resting block. So initially block has 0 velocity, so this is going to be block's final velocity. Initial velocity is 0 because block is not moving at the beginning. So I'm going to start off with the bullet momentum. So momentum for the bullet plus momentum block, and then it's going to be the same thing. This side, it is still bullet and the block, but I'm going to call them prime because it shows after the bullet goes through the block. So this is mass times velocity. Momentum is mass times velocity. I'm just going to plug it in. Mass times mass bullet times velocity bullet. Mass block, I'll call this BL times velocity block. And then here, mass bullet is going to be same. This is going to be the final velocity for the bullet, and then this is going to be the final velocity for the block, which is going to be prime. Okay? So here it's going to be 0 because, as I said, the object is not moving, the block is not moving at the beginning. I'm going to convert this to kilogram because I want kilogram meters per second at the end. And then what I'm going to do is I'm going to plug in the mass times velocity, and this is plus 0. And then the bullet is going with 200. This is kilogram, guys, and this is kilogram. And that would be meters per second. And this is going to be 200 meters per second. And the block, which has 3.1 kilogram, the velocity of the block we are looking for, final velocity of the block we are looking for. So here is the deal. You multiply this 2 and you get 1.47 kilogram meters per second equals, this is going to be 0.6 kilogram meters per second plus 3.1 kilogram, and then velocity of the block prime. I'm going to subtract 0.6 kilogram meters per second both sides, and then this is going to be 1.4 minus 0.6, so it's going to be 0.87 kilogram meters per second, and then 3.1 kilogram times velocity of the block after the collision. So I'm going to divide both sides. 3.1 kilogram and this will give you velocity of the block prime, I call it, because it is final, 28.28 meters per second.